Hi students, this is AJ sir. Let's study 10th standard ICSE Math, Chapter 5D, Quadratic Equations using the formula method. Solving quadratic equations using the formula. Many times we are unable to split the middle term of a given quadratic equation. In that case, using this formula makes things easy. If you remember, we had studied that if the value of this discriminant is a positive number or equal to 0, then the roots, that is the solutions of x, will be real. But if it is negative, then the solutions will be imaginary, and hence we could not solve it further. In exercise 5D, question 1, solve the Roman numbers 1, 2, 3, 4 because they are of the same type and are very easy. Let's start with Roman number 6. So this quadratic equation is given. Here splitting the middle term will be possible, and yet in the question they have mentioned using formula. So let's do it. First of all, comparing it with the standard form, we get the value of a as 2, b as 7 and c as 5. Using these values, find the discriminant, which comes out to be 9. And then using the formula, we substitute all the values. Note there is a plus and minus sign out here. So then we have two different values. Every quadratic equation usually has two roots. So minus 7 plus 3 upon 4 or minus 7 minus 3 upon 4. Solving them further, we get two values of x. These are the roots of x. Next, Roman number 8. This is the given quadratic equation. First, we write it in the standard form. Remove the LCM, cross multiply, simplify further, and we get x squared minus 10x plus 25 is equal to 0 in the standard form. And then by comparing, we get the values of a, b and c. Find the discriminant, which comes up to be 0, which means both the roots for this sum will be equal. That means we'll have only one answer of x in this sum. So substitute the values of minus b here to a, and b square minus 4ac is already found out. And the final answer is 5. Next, Roman number 9, mark it as IMP in your textbooks. First of all, we write it in the standard form. So here a is 1 because there is no coefficient. We assume it to be 1. B is minus 2 root 2 and c is minus 6. Now using these values, we find the value of b square minus 4ac. Note how, because of the square sign, minus becomes positive. 2 into 2 is 4, root 2 square is 2, and 4 into 2 is 8. That's how I got this as 8. Minus into minus is positive, 24. So that's 32. And now substitute these values. So you get this. Root 32. Whenever you see a big number under the umbrella, simplify it further. This is nothing but 2 into 16. 16 is a perfect square. So that becomes 4 and comes out of the umbrella, and poor 2 remains all alone under it. Now we have plus and minus, so let's separate them. So 2 root 2 plus 4 root 2 is 6 root 2. 2 root 2 minus 4 root 2 is minus 2 root 2. And now reduce further. And these are the final answers. No need to substitute the values of root 2. Although you may if you want to. Many times in the question they specify they want the answer in decimals. Then you have to substitute the values of the root as well. Next, the 12th sum. So again, we compare it with the standard form and get the values of a, b and c. Then we find the value of the discriminant. Notice here, minus into minus is positive. Root 6 into root 6 is 6. 6 into 2, 12. 12 into 4, 48. And plus 16 is 64. Substitute all these values. And after splitting them, or rather separating them, we get the two values here. Now we should never leave a root sign in the denominator. We should always rationalize the denominator. So into root 6, into root 6, and even here into root 6, into root 6, numerator and denominator, so that the denominator becomes rational. And then solving further, we get these as the final answer. Next, Roman number 14. Mark this as IMP. So first things first, the denominators are not the same, so we have to equalize them by removing LCM. Into x minus 4 up and down, and here into x minus 2 up and down. This becomes 10 upon 3, of course. Now distributive multiplication, x into x, x into minus 4, minus 1 into x, and minus 1 into minus 4, plus x into x, x into minus 2, minus 3 into x, minus 3 into minus 2. Then get the like terms together, do distributive multiplication in the denominator also, and you get this step. Then you cross multiply, then you get all the like terms together. So 10x squared minus 6x squared is 4x squared, minus 60x plus 30x is minus 30x, 80 minus 30 is 50, and only 0 is remaining on the other side. We can simplify this further, divide the whole equation by 2. So we get this. And now, comparing with the standard form, get the values of A, B, C, find the discriminant, and using the formula, solve as usual. Check. Are these the answers you got? Next, 2.2. Solve each of the following equations for x and give the answer correct to one decimal place. So we'll do Roman number 2 here. So first we compare and find A, B, C. We find the value of the discriminant and we substitute the value and solve ahead. Notice how I wrote 160 as 4 root 10 because 160 is nothing but 10 into 16, out of which 16 is a perfect square, so it comes out. If you can't get it directly, then do the prime factorization and break it up into the smallest parts and decide which pairs should come out. For example, this will become 2 into 2 into 2 into 2 into 2 into 5. So this pair comes out, this pair comes out, but this 10 remains under the umbrella, and 2 and 2 come out, so it becomes 4. So that's how 4 is out. And now separate them because it's plus and minus. Now here they want the answer in decimal, but accurate up to 1 decimal place. So you substitute the value of root 10, accurate up to 2 decimal places, 3.14. How do we find the decimal value of any square root? Well, the logbook will be given to you in exams. Right now you can use the square root table at the back of your textbook. Here we go, square root of 10 is 3.162. But that's up to 3 decimal places. If you substitute this value, it's okay. I'm going to use only the 2 decimal places, 3.16, so that in the end I can round it off and get the answer accurate up to 1 decimal place, which is what they've asked in the question. So after substituting these values, I get minus 10 plus 12.64 upon 10, minus 10 minus 12.64 upon 10. That's 2.64 upon 10 and minus 22.64 upon 10. I purposely did not try to reduce the denominator with the numerator because then dividing by 10 is so easy. I just have to shift the decimal place. So this answer is 0.264 and this is minus 2.264. But I don't need answers up to 3 decimal places. Let's round it off to just 1 decimal place. That means I want to put a stop out here. So the digit after that is 6. So definitely the digit before this will increase by 1. So x is approximately equal to 0.3. Similarly, I need to stop after 1 decimal place as per the question. So again, the digit after that is 5 or more than 5. So that means the previous digit has to be increased by 1. So the final answer here is minus 2.3, accurate up to 1 decimal place. That's why I put an approximate sign here. Now in question 3, cancel Roman number 3, 4 and 5 because they are easy and of the same type. Now let's do 3.2. First, I should convert it into the standard quadratic equation form by removing LCM of the entire equation. Then by comparing, we get the values of A, B and C. Come on now, don't copy, solve on your own. See what is the value of discriminant that you get. 73? Yes. And now, using the formula, substitute the values. Square root of 73, come on, you find it from the square root table. Let's see if you're able to use it properly. So I'm getting 8.544. I wrote it up to 3 decimal places because then I can round it off in the end and get the answer accurate up to 2 decimal places, which is what is asked in the question. So you separate them. Here minus 13 plus 8.544. Make sure you do this addition subtraction in the rough work on your own. Let's see if you know how to add and subtract decimal places. It may seem very simple, but students tend to make silly mistakes because of lack of practice. So please do it. And the most challenging part is the division part. Now here there is no trick. You literally have to divide it and get the answer in decimals. Don't use calculator. And then round it off. So up to 2 decimal places, so it will become 0.56 here, negative. And again up to 2 decimal places, so 2.69 here, negative. Next question, 4.2. Cancel 4.1, it's of the same type. In 4.2, we want answer up to 3 decimal places. So again we compare and we get the values of A, B and C. We find the discriminant and then using the formula we substitute the values. Now notice that 232 should be simplified as much as possible. If you look at the prime factors, it's just 2 into 2 into 2 into 29. So I can only remove a 2 out. The remaining 58 will remain under the bracket. That's okay. We have all the square root values up till 100. So we will substitute those values out there. Here, after separating, I did remove 2 common and then I cut 2 and 2. So that what is left is 8 plus root 58 and 8 minus root 58. And substitute the value from the logbook and we get the 2 answers. Do the subtraction on your own. Next, let's do 5.2. Now at first this doesn't look like a quadratic equation because the highest power is 4, whereas in a quadratic equation the highest power is 2. So in this polynomial, since the power is 4, we reckon that there might be 4 roots and not just 2 roots. But how do we solve it in the first place? Well, first of all, assume x squared as y, so that by substituting we convert it into the usual quadratic equation. Check if you can split the middle term. If you can, then do so. So minus 3 plus 1 is minus 2 and minus 3 into 1 is minus 3. Then as usual, the first 2 terms together and the last 2 terms together. Remove common, then the brackets are common. So we get y is equal to 3 or y is equal to minus 1. That is either x square is equal to 3 or x squared is equal to minus 1. But x squared cannot be equal to a negative number. How can, if I want the value of x now, I will remove square root of minus 1. That's an imaginary number. So that is ruled out. That means x squared is equal to 3 and the value is plus and minus root 3. So finally we have only two values of x because the other two values were imaginary, and in school level we don't have to solve with imaginary numbers. Notice how we didn't even use the formula in this sum because splitting the middle term was possible. Next, 6.2, mark it as IMP. Notice how the brackets are exactly same, this one and this one. That's the biggest hint that we have to substitute as, let's say, y, so that it looks like a usual quadratic equation, and then check if it can be split, and in this it can. So minus 18 into 2 is minus 36 and their addition is minus 16 as usual. So then you remove common and you get two values of y, but don't forget to resubstitute the value of y as x squared minus 3x. So finally we get two new quadratic equations, and it seems that each will have two roots. So totally we are going to have 4 roots. But how to solve them further? Well, if you can split the middle term, do that. But if either of them cannot be solved by factorization, then use the formula method. Even if you can split the middle term but you want to use the formula method, that's fine. In this case, I have split the middle term in both the cases and found 4 values of x, that is 6, minus 3, 2 and minus 1. Now 7.1, again mark this as an IMP. What is peculiar about this sum is that this term is actually a reciprocal of this term. So whenever you see something like that, we'll assume that term to be equal to y. So if this is y, this will be 1 upon y. It's a reciprocal of this. So we get a very simple quadratic equation, because after doing LCM and cross multiplying, we get it in the standard form as well. And then solve it as usual. If you can split it or you want to use a formula, your choice, because the answer is going to be the same. Y is equal to 2 or y is equal to half. But that's not enough. We have to resubstitute. Don't forget it. So after resubstituting, we get rid of the root sign by squaring both the sides, then cross multiplying. These are not quadratic equations, these are linear equations. So we directly get the values of x as 4 and minus 1 respectively. Next, 7.3 can be cancelled because it's easy. Even cancel 8 and 11 sum. Let's do the 9 sum and mark it as IMP. They want us to give the answer correct to 3 significant figures. Now what significant figure? We'll understand that shortly. But first of all, solving this is as usual. Get the values of a, b, c, then find the value of the discriminant, substitute. Root 89 has to be found out from the logbook, which is 9.433. Separate them, solve it further, divide by 10. That's easy. Just shift the decimal place and we reach this place. Now if you want 3 significant figures, it doesn't mean 3 decimal places, okay? For a moment, ignore the decimal value. So I have 1, 2, 3. That means I want the answer till here. Always start from the left hand side. So the next number is a small number enough to even be ignored without affecting the previous number. So the answer is 1.24 approximately, of course. And here again, if you ignore the decimal place, and this becomes 0.6433, and 0 has no value, so it is not significant, ignore it. So the 3 significant figures in this case will be 1, 2, 3 here. So I have to stop till here. So I can ignore this last term. So the answer is 0.643. No need to round up because this was a small number. Hi students,
If you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.